A single slit or a double slit is talking about a tiny little gap in a wall so that you can shine like one narrow laser beam and it more than covers the hole. And then this distance is something like 10 to the minus 4 meters. And then the distance to the screen is something like 1 meter, which means any beam coming from here and coming from here and coming from the center going that way, those angles all are incredibly close to like 5 decimal places or something. They're very close angles, so we're just going to call them all theta. Even though these two beams are going to meet eventually, we can treat them as almost perfectly parallel. So when we zoom in, you got to bear in mind that there's this huge distance, and then the beams will come together. Why does the single slit have a formula for its maxima different from the double slit? You can imagine the single slit as being a double slit that then had its center wall knocked out. What does that do to things? Well, before, with the double slit, we were interested in two beams of light that were going in almost exactly the same direction. We can treat this perpendicular here, making this angle here theta, just like this angle is theta and this angle is theta. They're not exactly the same. They're off by a tiny smidgen so that they'll meet eventually. The path difference, as with the double slit or the single slit, is this distance here from here to here. This is d sine theta. This is the path difference. Now, in the case of two slits, we were concerned about whether this was an integer number of waves. Because if it was an integer number of waves, say one wave, then this would have been shifted one wave over, and then from then on, these would have been marching in sync, and it would make a maximum. What's different when we knock the central wall out? Well, not only do we get a phase like this, and another phase wave like this, but we're also going to get all the other phases in between. And what that looks like, I'll display on Desmos. This is desmos.com. You click Start Graphing. It will take us directly into a graphing calculator. It's free. It's great to use. I'm going to type in formula like y equals sine x, and it instantly appears. Now I type in another wave, and now I've got two slightly overlapping waves. And I'm going to add a third one, and after that a fourth one, and I will cut ahead, adding on more and more waves, skipping ahead to save you time until we have a whole set. Now that's a whole mess of waves, but let's look at what happens when I start to add these waves together. I've added 2 waves, 3 waves, 4 waves, 5 waves, it's getting bigger and bigger, 6, 7, 8, it's getting smaller again, 9 waves, 10 waves, and it's all canceled out to nothing. That's what happens when you include all of the phases at once. Every possible phase, it all cancels. If instead we want to get a maximum, if we want these waves to add up and not cancel, we need them to be only off by half a wave. Because if this is off by half a wave, then these two ends are perfectly out of sync, so you'd think it'd be dark. But with everything else in the middle, it adds up. Again, let's look at Desmos. Here I've displayed 9 different waves, representing about half of all possible phases. I'm now going to start adding them together. I'm going to add up the first one, and the second one, the third one, the fourth one. You can see these are getting larger and larger, and we're not going to pass the halfway point, so it's not going to reach the point of canceling. This is what happens when you have half of all possible phases. The total wave just gets large. So that's why it's constructive interference for the single slit if you have only half the phases. To sum up, the double slit had constructive interference for d sine theta equals m lambda for m any integer. Destructive interference for d sine theta is m plus a half lambda. The single slit is the other way around. Constructive is d sine theta is m plus a half lambda. Destructive is d sine theta equals an integer number of waves. With the one exception, as I note, that in the dead center, where theta is 0, it's constructive interference. I hope this video has helped you understand why the two formulas are the way they are. Thanks a lot.